The derivation sheet explores the geometric principles that define the shape and internal structure of parallelograms, specifically focusing on the precise conditions under which their diagonals cross at a perfect right angle. To bring these abstract principles to life, the architecture utilizes two distinct diagrams: a sequence diagram to map out the logical flow of information and a state diagram to manage the visual evolution of the geometric shapes. The sequence diagram acts as the logical blueprint for the system's engine. It begins with a static plot where the system takes input vectors to render a basic parallelogram and its internal diagonals. The process then moves into a dynamic animator phase, where the length of one side is continuously varied. During this loop, the engine constantly monitors whether the lengths of the two generating sides have become equal. The moment these side lengths match, the sequence sends a specific trigger to the display to change the visual feedback. Finally, the sequence uses branching logic to classify the resulting shape, distinguishing between a standard parallelogram, a rhombus, and the specialized case of a square. Complementing this logic, the state diagram focuses on the user's visual experience and cues. It starts by providing a static view of the geometry, illustrating that perpendicular diagonals are not a default state but depend on specific side relationships. As the animation begins, the state transitions into a stretching phase, where the parallelogram physically changes shape while the screen provides real-time updates on the changing lengths and intersection angles. The most critical transition is the trigger state. When the side lengths become equal, the diagonal lines instantly turn red and a label appears to declare the shape a rhombus. In the final visualizer state, the diagram clearly differentiates shapes by their diagonal intersections: an oblique intersection for general parallelograms and a perpendicular intersection for a rhombus. A square is highlighted as a unique state where the diagonals are both perpendicular and equal in length, occurring only when the sides are equal and the vectors themselves are already positioned at a right angle.